Good morning, good afternoon, and good evening, everyone. Welcome to the second day of MMSys, third of actually the whole MMSys and co-located workshop conference. Before welcoming our keynote, just let me give you an overview of what we are going to have today as a program. We have our keynote, Eric Klein, session 4 on MMSys on creating innovative immersive experiences, session 5 on next generation media processing. And then, as we did yesterday, we will have the 2 parallel sessions of open dataset and software in the first Zoom virtual room, and then demo industry in the second virtual room. And as every day, we have our social event that today will be the N2 Women Networking event, Women Experiences and Connection. Okay. And let me see. Okay, so before also proceeding to our keynote, I just would like to remind everyone that we have 2 awards that are actually a great opportunity for you to win a free registration for an ACM 2021 conference, so an ACM conference next year. So don't be shy or lazy, and feel free to tweet as much as you can and post question on Slido as much as we can. The Slido tweets are really there to favor a little bit of sharing opinion and information in our community. And now, welcome to our keynote speaker, that is Eric Klein. So many thanks. Actually, we were hoping to have Eric here, but we had to wait a little bit before the confirmation. I guess all the launch of Disney Plus kept all the people at Disney busy. So Eric is from Disney Streaming Service, is actually the director of the content distribution at Disney Streaming Services. Is focusing on video content and optimization technology. Is a member of also Streaming Video Alliance as a co-chair of the Open Caching Working Group. So very active. Thanks, Eric, for being with us. He graduated from New York University with a degree in film studies. After that, he worked quite actively in all the industry at the beginning of Synapse Digital, working on public relation with many brands like Adidas and General Motors. Recently, he then went to, not recently, but he then went to Disney. And today is going to talk about live streaming at scale in a low latency world. So thank you for, again, giving this talk, Eric. I think you can take the lead and share your screen. Thank you. And let me also remind everyone that for sure you will have many questions while Eric presents his work. So feel free to post all your questions on Slido in the keynote Klein room, and we will go over that at the very end. Thank you again.
Thanks, Laura. So thanks for the introduction. I actually probably don't need to do much on it, but I do have one in here in the slide deck. Very quick overview of who I am, just for the call. So I'm Director of Content Distribution Management for Disney Streaming Services. That includes working with Disney Plus and ESPN Plus. Disney Streaming Services is a part of that, of a part of the broader Disney company. We grew out of Major League Baseball Advanced Media. We grew out of Major League Baseball Advanced Media, and as part of that growth and environment, we were also became a company called BAMTech Media that eventually became part of the Walt Disney Company. In addition to that, I'm also co-chair Open Caching Working Group for the Streaming Video Alliance. I don't know how many people really know about the Streaming Video Alliance in terms of, oh, give me one sec, sorry. It looks like I have auto timing on. I'd like to turn that off. There we go. Okay, great. So as part of that, as part of the Streaming Video Alliance, our goal really is to provide a forum for collaboration amongst different organizations that are both active in the ecosystem of day in, day out components to live streaming video and on-demand streaming video. That includes client devices, that includes storage providers for the servers and software that you might need to leverage. It includes standards working groups. So we work closely with members of the IETF working groups for the CDNI, or Content Distribution Network interfacing standards. We also work quite closely with internet service providers, everyone also from the metrics and measurement side of things, really looking at the holistic ecosystem in a practical manner, right? The best way I try to describe the work that we do is there's quite a lot of amazing theoretical work, and I was actually looking at quite a lot of the slides that were previously posted for MMSys and reading through them, and there's quite a lot of really interesting work and research going on, and our job is to really try to figure out, like, in the streaming video space, how can we take that work and best manage and leverage that for the practical use cases that we run into day in, day out. And I have a whole wealth of stories that I can share about practical use cases versus specifications versus what actually happens in a specific environment. But in short, our goal is really to try to provide a forum to increase and improve that interoperability scope. And in order to do so, create kind of an evolution to standards and specifications, or add-ons to standards and specifications that exist today. The open caching working group that I work on, I'm going to go into a bit about what open caching does later, as it's relevant to kind of the grand scheme of the distribution chain, but it really does focus on interoperability and collaboration in the space. So stepping ahead really, and actually, you know what, while I'm on it, one little quick note, Laura, I really appreciate you bringing up the note about film school. So I actually started in film studies, learning film overall and just the media ecosystem, and over time worked my way into just on-the-job learning, the technology side of video distribution. And I've been in the online media space for over 12 years now, and it was really just a learned process of learning from the core fundamentals of how things are done, from encoding all the way on through the process of where I really focus my time today, distribution and the performance optimizations you can make down to the TCP stack level, all the way through different caching settings and optimizations, as well as just understanding the video ecosystem as a whole. And so, you know, it's an interesting journey for me, but it's also one that I think is very much a telltale sign of the world that we live in from an opportunity standpoint in the online media space, which is you have the opportunity, if you have the interest in the right space, to dive in and show where you can perform. And a degree certainly helps, but it isn't the be all end all of kind of a full scale success in the space. So, you know, with that, just wanted to give a quick overview of what we'll talk about. So low latency streaming, I saw a couple of presentations that we had posted, that had been posted on it. It's been really a very hot topic that's been going around, and I wanted to focus a little bit on some of the key points that have been out there, some interesting components of it, and really how it starts to relate to scalability and how you can scale low latency streaming and at the same time take the specification approaches and the ideal approaches around distribution options and also marry that with the challenge of scalability. And how do you scale specific aspects of the workflow? How do you look at how distribution as a whole and the best ways that we can potentially deliver this type of content? And then I'll use that to transition into kind of a practical conversation. What does the world of content distribution networks and and then eventually open caching look like as it relates to live streaming, low latency live streaming, and even on-demand streaming, and just give a brief overview of the industry as a whole. For me, it's the world I live in day out. I actually was polling a colleague of mine that has come to a couple of these in the past, and you know, he suggested bringing a bit of this kind of practical approach of what we deal with day in, day out might provide some interesting additional insight. So I figured it would be a good way to share it. And then hopefully I'll look forward to some questions on that. So real quick, let's start at the top with low latency streaming. So low latency streaming is something that is quite a lot has quite a lot of focus on it. It's that goal to get as close as possible to something happening in the real world and when it displays on a viewer screen. When is the viewer able to see what's happening from glass to their glass, right? From the glass that it captures on the camera side to the glass that they get on their front end. There's quite a lot of use cases. I found a nice blog from Mux that really nicely summarized it, and I tried to kind of capture that and add a little bit of color to it. But in short, right, we have some primary use cases. There's voice and real-time communication, which is really that one-to-one target audience of low latency, where you really need to target that traditional latency of 0.2 seconds or lower. It's really the goal there is lowest latency possible. We see it nowadays with video conferences and the way we live, right? That we're more forgiving of little chops and little issues here and there, but at the same point, we need the conversation to be low. We need the time frame to be low and the conversation to flow. If you don't have that low latency, you're just not able to have the right interactivity needed. Auctions and UGC content has been something that has been around for a while in the space. From my standpoint, I've actually, when I was in my previous job at Limelight Networks, where I was a solutions engineer, kind of working with customers to figure out their technical challenges, I had quite a few customers come to us about auction time, and in that scenario, it was kind of it's a one to few audience. It's not like you're going from one point and trying to interface with thousands and thousands of viewers, but you do have to satisfy the needs of maybe a couple hundred or even just shy of 100 viewers. And in that scenario, you're really looking at latency that's 1 to 3 seconds so that you can have that interactivity, the ability to have someone remotely bid on an item or participate in an auction with some sense of real time. Traditionally, that's been done through RTMP, and it was for the longest time really the only mechanism that was useful to get that type of latency. But nowadays, there are some more options, and we'll mention some of those on the next slide. And finally, sports and events. This is the world I live in. This is the world that I concern myself in quite a lot. But with sports and events, it's targeting that one-to-many, those one user to thousands and thousands of viewers. So the one source, to thousands and thousands of viewers with, traditionally latency that's 10 to 30 seconds. It's done that it's behind real time by I wouldn't say quite a lot, but it's behind real time by a substantive number. The reason for that is you're ultimately looking for resiliency and stability at scale there. Your goal is not necessarily to deliver the content as quick as possible, but it's to deliver it as smooth as possible, so the user experiencing it gets to have the highest quality experience possible. The one aspect to note there is that we kind of at Disney streaming services have a phrase, beat the Twitter clock. So if we can at least beat the Twitter responses to things and how people are engaging and having conversations around the sports event, then we've succeeded. That's the traditional goal. Obviously, we want to improve that, and we'll go on the next slide to talk about some of the areas that we look at and what we consider some of the more low latency aspects of that framework. But these are really kind of three key buckets. There's obviously more use cases. Gaming is one that comes to mind, and that one is kind of a hybrid where a lot of gaming networks build their own infrastructure for things, and you're talking about traditionally incredibly low latency for gaming-based interactions. And even more and more low latency. But I really wanted to focus on low latency streaming in these use cases because it goes to some of the standards and formats that are happening today. There's often different ways to solve the problems based on the concerns and challenges that you're facing. In some scenarios, with latency just being one factor, you're going to make prioritization choices in terms of what formats you deliver content in and how you specifically deliver it. And, I have a note here on the fact that, this is the low latency format for content. There's obviously low latency transport as well with different aspects, but we're really looking at the video formatting aspect of things as it relates to the construction of a media package, as it relates to, in turn, the choices we make on the distribution side. And we're still looking at these as, at least in the case of LLHLS and LLCMAF for Dash, more of a traditional HTTP-based delivery mechanism. The WebRTC one is obviously a socket-based connection, so it has a different type of environmental experience and different concerns that show up. Again, going through those 3 different use cases we laid out before, voice and real-time communication, it's still that 0.2-second target for low latency instead of just a traditional latency target. It's still that low target. And really today, the way that it seems to be taking on in a low latency format is through WebRTC or existing formats, RTP, any time of the RTP-based formats. Auction and UGC still remains that 1 to 3 second latency target. If you can improve that, great. But it isn't something that today has really been pushed too far to the limits. And there it's, WebRTC. You could also solve that with LLHLS, LLCMAF for Dash as well. And then the existing formats is RTMP was what, as I mentioned, what we traditionally used in the past. One of the things I'd like to point out about LLHLS and really briefly touch upon it is, that it is still something that is being refined through specification. Apple's come out with a couple different variations and options on it, and we'll talk about those. But in short, it's a flexible format. You can get latency that's lower that still takes advantage of the HLS spec, but doesn't necessarily require you to go fully low latent and do all of the features and functions that they necessarily recommend as part of the revised specification. But you could also maintain and leverage just some of the features such as chunk transfer encoding to reduce the latency time of a segment while still maintaining and being built on a lot of the traditional HLS paradigms that we operate on today. Finally, the sports and events use case. So a note, right? I referenced the MUX article that I saw that I thought was really interesting in the previous slide. That low latency target for them actually labeled live sports as 1 to 3 seconds. We at Disney Streaming really consider 3 to 6 seconds a more ideal target. And the reason we say that is we've done some work in the past, and if we look at what happens with a cable TV experience within the United States, it's traditionally 3 to 7 seconds behind when the actual object or event occurs, when it's captured, minus any delays that you put into the broadcast infrastructure to add in actual delays by choice. And so our goal there is to not necessarily beat that time frame, but to match that time frame for consistency purposes as well as for ease of integration. If you're serving content with ads, you do need certain segment lengths and certain standard pods and structure that enables you to more easily manipulate the content so that you can have consistency from a segmented delivery standpoint for both your main media segments as well as your ads. And so while you could in theory get latency incredibly low for sporting events and get it to that same 1 to 3 seconds that you're looking at with auctions and UGC, for us, we really think of 3 to 6 seconds as a reasonable, responsible, and ideal time frame for sports and events. It gets you to still get on par with all the existing broadcast experience, but it helps you maintain some of the standards and integration requirements that you would traditionally need to think of an entire larger practical ecosystem than necessarily just getting that best of class performance out the gate from a time frame standpoint. Again, right, sports, we have LLHLS, LLCMAF for Dash. I put WebRTC there. Personally, I put a little star because I wanted to make a little comment. I think WebRTC is a really strong format, particularly for the one-to-few and the one-to-one communication conversation. But for a one-to-many conversation, so that large-scale event, I haven't seen the proof yet that it scales incredibly well, just because of the infrastructure that's needed to support that. So I put it there. It is a format that can be used and can be recommended. There are providers out there that are leveraging it and offering it as a solution. From my personal standpoint, and this is just more of an opinion, I think there's room for it to grow and there's opportunity for it to potentially scale better in a non-infrastructure dependent way. And at that point, potentially becomes a strong option for a large scale sports or event challenge. But for now, really the focus for me and for those of us at Disney Streaming is on those low latency chunked media delivery or adaptive media delivery packaging and options. So jumping ahead, I wanted to really look at the use case of live sports. The desire for low latency where possible, but still really looking at stability and scale. The target is ultimately that we have consistency for all of our audiences rather than necessarily the lowest latency experience for some of our audiences. Again, as I mentioned, WebRTC works for smaller scale events, but when you look at something like LLHLS that's just got introduced, it's really looking at those smaller segments via modifications to the existing HLS standard. LLHLS, I didn't put it on the slide. I wanted to kind of briefly just talk about it, but LLHLS has quite a lot of different features and functions. Query parameters are used heavily within that environment to kind of dictate the specific aspects of when a user joins a stream and try to make the stream as specific as possible for that user. It also introduces this concept of kind of micro segments that make up larger HLS segments when it's complete. And those micro segments enable you to basically break up a larger traditional HLS segment into smaller sub second segments that in turn are only used for a short period of time when the user first joins a stream. So the easiest way to describe it is a user comes in and receives a initial request at sub-second, at microsegment 5 of 10 within a 5-second segment. So effectively they're coming in at 2.5 seconds into a stream, and you start them with that sub segment, and then eventually they transition just to the normal traditional segmented media delivery. The benefit of that is that it helps really enable users that are joining the stream at any time to get the most live and up-to-date aspect of the delivery. Some of the challenges are that around query parameters that you need to leverage there. It can lead to scale challenges. Query parameters when it comes to content distribution can sometimes come up and interface with this thundering herd concept, where because everything is unique for each user, you start to overflow the entire workflow, whether it be edges that are within a CDN to the parent caches within a CDN, which in turn come back at an aggressive state to content's origin or where you're hosting the content. And if that happens at just the right time across the entire board, you end up with this full-on thundering herd that could ultimately risk your stream. And so that again comes back to the concept of weighing the low latency and weighing the flexibility and benefits you gain there with the ability for scale for the largest amount of customers, and really trying to balance the two of them. One note also I put on the slide, H2 server push. It's something that is leveraged heavily in the initial specification of LLHLS. It's since been revised. And it's one of those things where it starts to run up with specifications and standards versus practical applications in the real world. And I bring that up because we go into the reach of standards, right? The practical application of HTTP 2.0 is that it's currently only supported by roughly 30% of the top websites online, right? Netrray.io I found this interesting stat from there. It's an internet observatory. And really it points out that, of those top million websites, only about 300,000 were supporting HTTP2. And the question then becomes, well, why? And it's really about this competing requirements concept, this desire for pushing standards forward and moving standards at scale, but at the same point, ensuring stability and backward compatibility for all. H2 push is one of those great examples. The low latency HLS specification really placed a strong emphasis on it at the start. But if you start to look at the scale of how many servers are supporting it, how many CDNs and content distribution networks are supporting it. It's leveraged, it's supported, but not all the features and functions of HTTP2 are really supported, right? If we look at this specific list, it's H2 enabled infrastructure. So just the infrastructure itself, not even the website leveraging the specification, but the infrastructure itself is only at roughly 35% support for HTTP 2.0 standards and requirements. And so, it's one of those things where you kind of always have these competing interests and challenges of standards plus practical, and how can we get the best of both worlds to really marry them. One of the providers in the space that try to do that are content distribution networks for distribution or delivery purposes. And that's really my area of expertise. So that's the area that I'll focus the rest of the presentation on, is how do CDNs, and in turn, the work we're doing in the SVA for open caching, really give you a sense of standards and practical. Brief overview just on CDNs and content distribution networks, because I've dived into presentations before on CDNs and realized that for a lot of people, it's just this black box that doesn't give a lot of information. So wanted to give some background. CDNs are globally distributed networks of caching servers owned by, in this case, commercial providers that focus on high availability and performance for end users above all. And key CDNs can include things that they focus on: web delivery, security, media delivery and distribution, as well as just traditional infrastructure scale, and in some cases computed edge. And some of those companies are moving towards that. But ultimately, the key features of a CDN are that they're highly interconnected to ISPs, that their goal is ultimately to store content as close as possible to end users in them, or to get the most performant delivery to end users. And that's an architectural conversation that we can dive into if people are interested in the Q&A. In the case of CDNs that I work with, it's really about the optimizations for video streaming and the role they play in the ecosystem and the feedback they provide. CDNs certainly support H2 and support push. And so it's why it was originally recommended as part of the specification for LLHLS. But when you also look at the practicality of how far they support push, HTTP 2.0 push features, or how far they support all the HTTP 2.0 features and functions, it sometimes weighs where and what aspects they need to focus on their roadmap, because they have so many different optimizations they can do for video streaming. Is that one that's necessarily going to help as many customers as possible and help it continue to enable scale? There's also the ability for CDNs to have insight into end user interaction with content, just based on logging and the data points that you can capture from there. But ultimately, they do provide a centralized control environment. I, as in my role in content distribution, don't necessarily need to go to 50 or 60 different internet service providers to get content distributed and delivered. I simply can work with CDNs who have that infrastructure and that support in place, and have a centralized control over our configurations, our caching requirements, and our ability to scale out, all from some centralized partners. So a little bit of history on CDNs as well. Caching's obviously been around for a while, but in 1998, Akamai, which was founded on MIT research, focused on how to route around congested routes on the internet and leverage caching in a new way. And the goal was ultimately improvement delivery of websites. Since then, Akamai's obviously grown quite large. Their focus on architecture has changed, and what they do has changed. They still have that congested route delivery mechanism. They call it SureRoute. But they also have quite a lot of architectural kind of backbones and large scale core node development that they do to adapt and scale with the changing requirements of the internet and their customer delivery needs. But Akamai is just a few of the CDNs in the space: CenturyLink, Limelight, where I used to work, Fastly, CD Networks. Verizon has a CDN called Edgecast. Comcast CDN, Cloudflare, Ericsson has UDN that has been folded into some other groups, but that's still around and part of things. StackPath, actually CenturyLink I know is speaking or has spoken in a panel, and they have StreamRoute that's now part of them. That's kind of a different CDN aspect, but that's more of a peer-to-peer approach that ties into a CDN. But the industry just grows. There's so many different options Everyone does things in a similar manner, but they each have their own flavor and flair to what they're bringing. Again, the role of CDNs in general is that caching, that delivery at scale, that stability, and ultimately providing importance for the health of the internet. CDNs are one thing that really became crucial to the ability to continue to deliver at scale some of the challenges during recent times where people were inside during the pandemic. It helped, at least from my standpoint, enable us to figure out best ways to market and to work with commercial CDNs to figure out, how do they balance their traffic, and in turn, could they impact the whole internet? In their scenario, it's a matter of, well, if they have video game download customers and they make up a large amount of their customers, the CDNs actually have the ability to talk to those customers and have them adjust when and where they might be delivering some of that traffic, and in turn free up capacity for distribution and delivery during a daytime. So they play an important role in the overall health of the internet and the connected tissue that makes a lot of it happen. In addition, they provide those services we mentioned before: media packaging, web performance, security services. But one thing that I do want to point out about CDNs in general is they really do have a strong role in the media ecosystem. They help grow the reach of standards. It's their participation in these standards and in talking about them and in helping define them that add to the conversation of, what are different ways that you could take that practical and that theoretical and bring it together. They have research arms, but then they also bring it back to the practical standpoint of, what are some of the challenges that customers are facing. They encourage adoption of features. HTTP 2.0 being rolled out by a lot of these CDNs, at least a majority of the features, help it grow. If a CDN has that function available, it instantly becomes well, I may as well use it because it's there and there's no challenge. In the case of when I first started at MLBAM, we had started to use IPv6, but we hadn't really placed a lot of heavy emphasis on it. And we had CDNs that were just like, hey, we have IPv6. Would you like us to enable it? From my standpoint, it's a very simple and easy change for customers that can benefit. It's fantastic because we're encouraging the adoption of this new this new mechanism for delivery. New mechanism for delivery for now. We'll go with that. But in short, it's encouraging adoption of a new standard, and that new standard and the role that the CDNs can play in that space are really important and helpful. And ultimately, they have in-house experts that can feed back to the larger ecosystem, kind of a conglomeration of, we have a bunch of customers with a bunch of different information. Let's try to merge that together and use those learnings to help the industry grow as a whole. And that kind of takes us to open caching, right? Open caching is kind of in some ways it's an evolution of that. It's trying to add to the forum of conversation, not only CDN voices, but also content providers that are getting more and more active in this online media OTT ecosystem, as well as internet service providers. And so a little bit of background, open caching itself was developed within the Streaming Video Alliance. And as I mentioned before, the Streaming Video Alliance is a group of different organizations all around the streaming media ecosystem, everyone from quality of experience providers to streaming video providers or content providers in our case, to internet service providers and CDNs as well, all looking at evolving standards to bring some practical real-world applications into the mix. And in our case, we offer specifications in the open caching working group around some potential ways you could build your own CDN network built on top of CDNI. But we also look at interoperability points, ways that a CDN, an internet service provider, a content provider can all work together to provide a smoother, scalable experience that could ultimately, hopefully, take something like low latency streaming and some of the challenges it presents at scale and make it more ubiquitous and no longer a challenge. So open caching is an evolution of that traditional origin CDN or content provider CDN ISP relationship. In this case, it's the content provider who used to go to the CDN, emphasize the standards, and then the CDN would work with ISPs. Now it's really bringing in all of us into the mix and having those conversations together to try to figure out a way that's more inclusive of all the concerns and challenges, but still built on standards that are out there. CDNI is a standard that is developed within the IETF about some CDN specific features and functions that can be adapted, and some recommendations on API interfaces for that. Whereas the Open Cache Working Group, one of the things we're doing is focusing on the architecture side of things. Ultimately, our goal is to expand the trust and transparency throughout the entire chain and ecosystem. Real high level, how does it work? And I'm trying to be conscious of time so we have enough time for questions. The open caching solution is composed of multiple different components. There's request routing, distributed caching rules, detailed logging, and content management. And those are really the fundamentals and framework of the open caching workflow, which is, again, this mechanism for you to construct your own CDN-based solution. But it also has a lot of things driven from real world use cases in a very practical manner. Tokenization, quality of experience metrics, best practices, configuration, integration APIs, and capacity insights APIs, all about the interoperability and interplay of CDNs, of ISPs, of content providers, and the different concerns and requirements we all have. Components of the solution, each open caching setup requires a request router, an open cache control, and an open cache node. And it's, again, these integrations with standards and needs, the CDNI framework, existing workflow needs, and broad use cases of all of the customers in the ecosystem to handle it. And the goal ultimately is that this will help reduce latency and potentially, hopefully, improve low latency streaming opportunities and distribution opportunities. Today, it's really about VOD-based delivery as a ultimate goal and target, but it's not exclusive of that. Live certainly will work in this environment and paradigm. And while you might add a little bit of latency to an initial request in the chain, you ultimately do have quite a lot of improvement in performance. I'm laying out some workflows that we have. There's a redirect workflow, and here's the control plane or way that things would manage. I don't really want to belabor the time by going into this, but if anyone has any questions on this, we'll certainly provide the slides to Laura and Ali so that they can post it up on the agenda. But in addition, if anyone does have questions, I'm certainly happy to dive into this at another time. Really quickly, talking about open caching and its proof of concept trials. So there were multiple trials done in open caching. In late 2017 and in late 2019, we performed 2 different proofs of concepts, all of this towards path to production deployment, which is actually some of the work that's ongoing right now with some of our partners in the space. The ultimate goal is to improve scalability, right? It's, again, that scalability drives all. Low latency and specifications are fantastic, but when you're delivering in a large scale world for multiple customers, scalability is your biggest concern. Scalability and consistency of performance. And so here it's looking at things that we can do to support that. In this case, we improved the average bit rate during POCs from a 5.2 megabit per second stream to a 5.9 megabit per second stream, where the source stream was 6 megabit per second. So you're really hitting that high end of the stream and able to consume the entire experience, all just based on the sheer fact that you're able to increase the distribution and delivery aspects of the experience. The goal is ultimately a reduction in impact and quality of experience metric, but the trade-off to that is that it can sometimes add some initial latency. And the reason I point up initial latency is we talked about different latency times before. The initial latency here that it would add is sub 200 milliseconds for an initial redirect. Once that redirect happens and you receive a playlist, in an old school paradigm, the non-low latency world, it could lead to an extra 10 seconds of latency when you come into a playlist. You come in too late, and therefore you end up having an older, staler version of the segment. But this workflow actually marries very well with some of the proposals for low latency streaming at scale, where you have these smaller segments and you have this chunk transfer delivery where you're kind of able to come in in a playlist at a later time and still get as close as possible to that real time. Or you're able to come in to an environment with segments already partially downloaded and ready to go and being streamed to you as they're being written as part of chunk transfer encoding. So there's options, there's things available that can really satisfy both low latency and scale, and it's on its way and it's coming. Open caching has already begun to be leveraged in internet service providers, and it works in concert with CDNs, ISPs, and content providers to expand adoption. We're always evolving these proof of concepts and finding new use cases, getting these use cases and these POCs and these standards driven, not necessarily just from what type of new technology we can bring to the table, but what are the real world challenges we're facing? That is really what drives a lot of these standards and specification requirements we build. There's a link in the deck to a white paper that we have, as well as detailed links to all the specifications for anyone that's interested. So when you get a chance to look at the deck, certainly feel free to browse through there. But really, to sum it up, right, I want to point out latency and scalability aren't exclusive, mutually exclusive. Both can happen. But latency providing closer to real-time experience, ideal for certain live streaming events, means that scalability and the trade-offs there need to catch up, right? It may not always align. And so new approaches are trying to figure out the best way to do both. I really think, in the case of low latency HLS, which I focused on this in this conversation, it evolved from a standard that included some features that made that difficult, such as a strict requirement on HTTP 2.0 push and a strict requirement on certain query terms and parameters. And it's actually evolved over time based on feedback from the marketplace to one that's now really suggesting that is the best practice, but also offering means and mechanisms to use more traditional scalable options such as GET, just a standard GET rather than the HTTP 2.0 push, or reducing the query parameters and in turn reducing the complexity of what you may or may not have to cache at scale, so that you can have more and more content, more and more improved efficiency within the distribution ecosystem. Ultimately, CDNs still remain part of that solution, right? They have a way to scale that has a broad impact. They have a focus on low latency within their organizations, and they continue to provide that feedback. But they do have a challenge, and that challenge is ultimately, how do you manage customer roadmap features with adopting standards and pushing standards forward? And one of the ways that we try to face that in the Streaming Video Alliance is through open caching. It looks at those standards and it says, well, those standards are fantastic, but here's some recommendations we as a working group of CDNs, internet service providers, and content providers can go back to you with practical real world challenges that we face and ways that we can marry those into or adapt those in alongside specifications and make recommendations as a whole. It's for me, the goal is ultimately, how can we get to a point where we're doing full large scale live events with as low latency as possible for live streaming? And to do so, I think, it takes all the different components in the ecosystem and the chain, but we can really just expand existing systems with the practical learnings that we find and some of these new ideas that are being presented in the standards, and find a nice, happy kind of marriage and medium. I have about 15 minutes for questions. I'd hope to have a little bit more. So, hopefully we have enough time to cover those. And if not, we'll figure out another way to do it. But thank you everyone for your time. If you want to reach out to me, there's my LinkedIn. Certainly feel free to send me an invite or send me questions there. And also just Disney Streaming Services. I wanted to point out that, we're continuing to grow our team as best as we can in these challenging times. And so there's always opportunities posted on that specific link for anyone that's interested or hoping to learn more. With that, I guess I will stop the share unless we need it. I can always reshare if we have to. But
I'll share the questions, Eric.
Awesome. Perfect.
All right. First of all, thank you so much, Eric, for summarizing all these important issues. A virtual applause for our speaker. So, okay, let me share the questions. We have quite a few questions, and let me. you should be able to see them on the screen as well, Eric. So,
yep.
Okay, we will start with the most popular questions. People can upvote the questions. So, all right. So the first question is from Christian. He's asking which areas the academia should work in the area of low latency. Where do you see the biggest problems to be addressed in the near future?
Yeah, that's a great question. I think the academic work in low latency will really be on looking at those standards and determining which ones based on performance work out the best. The challenge that we have right now is the low latency scaling out for things like standards like LLHLS are relatively new. So you're in a kind of challenging model. Do I deploy it now and do I deploy it early and learn in the real world and make those challenges, or do I start to gather other people's experiments, gather other people's work and what they're doing on distribution for scale. And so, from my standpoint, people investing in and focusing on the learnings of here's the different formats, here's maybe some TCP recommendations to go along with those formats, here's the test results that we find in a lab-based environment around low latency. I think that's the most fascinating thing. The biggest problems to be addressed around it are ultimately the scale and the standards that are requested and needed to get those to be adopted. And the best way to get that adoption to improve and be carried over time is ultimately to have the support of research that's done on it that suggests these are the learnings and findings. If we could just get the support behind it, it would be a strong way forward.
Okay, well, I'll make just an add-on question on top of Christian's. So does Disney support any research activity in the sense that like work with the universities or provide some funding to some research projects? Are you guys open to such collaborations?
Sure. I can't speak for the Disney company as a whole. I do know that we are very strongly involved in different academic institutions and different organizations that are in the technology space. One of the things I would say is we have a very strong internship program that we place a lot of emphasis on bringing in interns and working with them. And in my scenario, I brought an intern on this past year who really I enabled to focus on a bit of research while at the same time focusing on some of the practical needs and applications that we deal with day in, day out. So there's definitely support in that environment. I'm sure there's plenty of things in that area, and I can certainly take that as a follow-up if people have specific questions or reach out to me on it.
Perfect, thank you. Okay, second question is from Mark. He's asking a question on behalf of his granddaughter.
Sure.
Wondering when Frozen 3 will be out.
Great question. I'm kept as far away from content as possible. My job is to make sure it gets delivered. Everything else about it, I leave to our content operations team and our studio team. I'm sure Frozen 2 had just come out, reached Disney Plus a couple months ago. Where it goes from there, I will be just as pleasantly surprised as everyone else. I think for me, the announcement that Hamilton was coming to the platform on July 3rd was just as surprising and as exciting for me as it was for the general public. So
yeah, I will mention that. All right. A technical question is next. This is coming from Abdul Haq. Can you elaborate more on how the encoding process, packaging, and ingesting impact the latency in CMF low latency? And do you have, maybe this part is more important, do you have any recommendation for the best encoding parameters in terms of chunk and segment durations, gop sizes, that sort of thing to reduce the latency further?
So we have a team that's completely dedicated to our core media development, our encoding, the work that we do there. So I will only gently step into this one for fear of impact from them. I do talk to them and work with them quite a lot. I actually, one of the gentlemen who ran that team used to handle our CDN stuff. So my kind of evolution at Disney Streaming has been through partnership with those teams. But in short, I would just say, there's certain things to keep in mind around low latency. Segment size is really the big one. And so when you're looking at how you want to distribute and deliver content, it's ultimately client devices that need a certain amount of segments within a buffer before playback will begin. You have an ability to define that segment duration. It is related to GOP size. It's related to keyframes. It's around finding the right moments within media that are both optimally efficient and don't impact the overall quality of a user experience. And then in turn, really dialing in that segment duration so that it's low enough that you get good performance, but that it's low enough that you get as quick and lowest latency as possible, but high enough that you still have good performance and good stability and consistency in the ecosystem and chamber, the workflow chain as a whole. We consistently look at segment duration size as an environment that are areas we can make tweaks and adjustments to. But ultimately the content that drives that decision, Dolby Vision content, for example, can range in segment duration from 500 milliseconds all the way up to 8 seconds or even further, just based on keyframe intervals because of some of the scene specific encoding requirements there, right, or rather metadata specific encoding requirements there. So there are options and ways to change things around the content. But when it comes to live content, that latency and that stability is driven ultimately by a stable segment duration that gives you the scale that you need, but still gets you as low latent as possible.
As a matter of fact, there was a talk yesterday about the variable segment durations and what to do with them, how to pick them based on the content, and so that's apparently is also something you're doing in practice. All right.
Trying to, yeah.
Next question also from Christian. H2 support is increasing, but I wonder which of its features, and probably also the same question for H3, are needed for efficient low latency support, also within the CDN. CDNs have been optimized for HTTP 1.1, but we are seeing more and more H2 and some trials on H3, and then maybe some of those features will be crucial for low latency support. So.
Yeah. Great point, Ali. I would just add to that, right? One of those features that stood out to me in the low latency specifications was the use of push. There's quite a lot that's that was already being done around request collapsing as part of H2 that really is standard these days. CDNs used to do it, and it's by themselves independent of H2 support, and then H2 support just kind of codified that. There are some things around the push side of things that still are interesting that could provide efficient low latency support. But quite frankly, to me, a lot of the features that you need for low latency exist today within HTTP 1.1, outside of potentially some of those components and environments around just lost my train of thought. Outside of some of those components and environments around request collapsing and request management.
Okay, makes sense. Thank you. So next question. Well, this was from mine, which I asked first. So well, probably you don't have an answer for this one either, but how soon can we expect global Disney Plus services all over the place?
I'll give you the best answer I can. We continue to roll out in different markets at all times, right? We've launched in the United States, Canada, New Zealand, Australia, and the Netherlands back in November. We rolled out quite a lot of countries within Western Europe in March, and we continue to grow and expand from there over the next 2 years or so. So you're going to continue to see aggressive rollout from Disney into different markets and different regions. And when the time is right, our marketing teams, our product teams, and our content teams will make sure that the world knows. They do a fantastic job of doing that. And on the technology side, we're kind of there to support them to make that happen.
Perfect. And can I ask whether you use open caching at the moment for any of those international deployments?
We are in the process of evaluating 3 different open cache deployments. I would say that two things on that. One, we have ones that are very close to production ready that we're looking to go. So you might, if you sniff our traffic, you might start to see it relatively soon. The second thing is anyone that is in the ecosystem that has their own content distribution network, whether it be an internet service provider or CDN, that really adapts to those open cache standards, we're always willing to talk to you. We really feel like those standards make our lives a lot easier because they're standards that we've been involved in and we know quite a lot about, but they also make the workflow chain really clear. It's the same workflow, it's the same recommendations and the same setup. So we're always happy to engage on conversations on that front if anyone has any open caching. You can reach out to me and then I can get you in touch with kind of our business strategy team on the distribution side, and then together we work in concert, me on the tech, them on the kind of requirements around the tech and what else is needed from a business and strategic standpoint.
Perfect. Thank you. Just a couple of more questions. I'll continue with Hadi's question. Will it be possible to deploy new video codecs like BBC or AV1 in low latency streaming, and maybe not just also not necessarily limited to low latency, but in general, are you guys looking into newer codecs like BBC and AV1?
We consistently evaluate codecs. I leave that to our core media team to do. I don't see anything in this specification that requires specific codecs as much as the packaging components of it. Yeah. So I could be wrong, but I don't necessarily think that codecs are specifically related to low latency. I think it's more about the packaging of the said content, but yeah. I'd have to do a little more research just to verify that. For me in the world that I live in, we handle things in a couple of different codecs based on the different platforms we need to reach. And personally, I can use iOS devices for a majority of my testing just out of ease and stability. And so majority of what I'm consuming is H.265 and H.264 encoded content.
Makes sense. All right. Next question is also from Applehack. He is asking about Quick. He says Quick doesn't currently support CTE in the sense HTTP does. And any idea how to run CMAP-based low latency with Quick? Or did you maybe, you can also ask whether you made any testing or evaluations with Quick for low latency?
I haven't had a ton of time to dive too far into how Quick would work with low latency delivery. Obviously, the mechanism of Quick is ideal for low latency, right? It really changes that traditional TCP challenges that show up. So there's obviously a room for it within that distribution standpoint. And I can see evolutions with H2 where Quick would become that de facto standard and you can leverage it as a distribution chain for delivery. The CTE components of low latency are just one approach to it. They're not necessarily the only approach. The Apple HLS specification doesn't necessarily call out chunk transfer encoding as much as smaller segments that could in theory be delivered via a Quick-based mechanism. My whole thing with Quick has always been that until Quick also supports forward error correction, you lose some of the benefits of it. You gain some in performance, but when you're delivering video streaming and the goal is ultimately consistency, you also want to make sure that the bytes that get dropped along the way are sent along the same pipe. Yes, it might be faster, and I haven't had a chance to properly test, like, is it faster for me to send the packets over Quick and then to have to resend the few to close that gap? Or is it faster for me to go with Quick plus forward error correction? So I think that's an area that I continue to look into and find interesting as, how far do we get with Quick with FEC, with forward error correction?
Perfect. Okay, one last question.
Sure.
And I want to switch the gears over here. WebRTC. So Reza is asking, he's saying most of the proprietary low latency live streaming solutions use WebRTC. Okay. And is there a public WebRTC version to tackle vendor lock-in and skill limitation limitations, challenges, and so on. So I guess the question is really, is there any public or maybe open WebRTC implementation that we can all use and they don't get a vendor lock-in if you want to do that?
It was my understanding, and maybe, yeah, WebRTC.
It's an open standard for sure, but
yeah,
there are so many different startups around this now, right? And
yeah,
they are doing something different.
Yeah.
And
yeah, so I mean, WebRTC as a standard is available and open. There's a lot of different companies leveraging it and implementing it. I don't necessarily know, like, it's challenging, right? Vendor lock-in means that it gets you spun up quicker and you're able to more swiftly kind of get going with those features. But I don't think, and this could just be that I haven't read up on it in the last couple months, but I don't think there's anything that precludes you from leveraging WebRTC in an environment that you build. I just don't know if there's necessarily tooling today that enables you to do that. I'd encourage you to check out the IETF spec on it. Yeah. RTC Web is the IETF spec, just to see if there are ways that you could potentially adopt it into builds of some open source tooling that you're looking to use. But I don't necessarily know if there's a lock-in as much as just the fact that vendors have deployed it, so it makes it easier to leverage them. And again, it comes to that question we brought up before, and why I don't necessarily, personally, it's my personal viewpoint, I don't necessarily think it's the strongest way forward for a one-to-many event, so those large sporting events, is because ultimately it requires a lot of infrastructure to get that done. It's a socket-based connection that requires a lot of infrastructure to get that type of streaming done. And so it means you're either looking to cloud providers to help you get spun up at scale, or you're doing a one-to-few off of a home server, right? It's great for a test lab, but when you're looking to deploy things at a broader scale, it's a bit more of a challenge due to the fact that it is that socket-based connection.
Understood. And Reza, if you wanted to mean something else, feel free to reply to your own question, and hopefully Eric will have a chance to look at those questions later on in slide that you might have another answer for you. All right, thank you so much, Eric, again. I really would like to emphasize that this new streaming has been growing very quickly and very rapidly, and quite largely. They have many opening positions for full-time engineers, I wasn't aware of the internship program, but that might be a pretty good opportunity for all the grad students attending this conference. And in case you are interested, feel free to look at the Disney website and maybe reach out.
I think the internship program right now for the summer is locked. I don't know how the fall will proceed.
This summer is a bit, I don't know. I mean, who knows what's going to happen with this?
It's going to happen, but it's certainly there. It's a great program. It keeps growing. So I highly recommend it.
All right, Eric, looking forward to your slides, and I will post your YouTube stream as well on the website. So anybody who missed the keynote can watch it later. Thank you so much again.
Thank you all. I really appreciate it.
Thank you. All right, everyone.